Hi everyone. The goal of this video is to learn how to calculate combinations. So we already kind of talked about classifying the difference between a permutation and combination. We will review that, but then we'll learn how to make some numbers happen. So quick reminder, permutations is when the order matters, combination is when it doesn't. So the best way to think about this is this example I wrote in here. Okay, in a permutation, Max, Trevor, Sophie is not the same as Trevor, Sophie, Max. So if Sophie got third place and then she got second place, it wouldn't be the same thing. And in combination, order does not matter. So Gray, Charlie, Mara is the same thing as Mara, Gray, Charlie. So what I would kind of compare that to is if I had 3 cookies and I gave out those 3 cookies, giving cookies to Gray, Charlie, and Mara is the same thing as giving cookies to Mara, Gray, and Charlie. They still get a cookie. It doesn't really matter the order. In this video, we're going to start with the formula to calculate a combination. And to derive this formula, I'm going to compare combinations to what we know about permutations. So first, our general formula to calculate a combination, and the notation, I suppose. So combination, we use C, permutation, we use P. And just like our permutation formula, N is like the pool you're choosing from, and K, or I think we use R in another context, but this is the number you want from that pool. You can write that however you remember it. Now, if we're calculating a permutation, the formula or the notation looks like this. And the formula for a permutation, I'm going to write this off to the side because this may come in handy later. So remember that a permutation of n, and you're choosing k, is n factorial over n minus k factorial. I know in another context we used r, but just think r and k are the same thing. Okay, so basically a combination you can always write in terms of a permutation. A combination is you take the permutation and divide by k factorial. Okay, so what this really means is you're going to find the permutation to pick k people from n, so that's the permutation part, but then you're going to divide because there are k variants, which kind of means like repetitions. There are k repetitions. So if you kind of put those things together, the actual formula for a combination is n factorial over n minus k factorial times k factorial. So this formula part is the permutation piece. And all you've done is also divide by k factorial to take care of any variance or repetitions. Let me give you a quick example to see where this makes sense. And let's kind of continue with our Mara, Gray, and Charlie context. And let's say I'm taking those 3 and I'm picking 2 of them. And I'm picking 2 of them to advance in a contest. So we're going to still go with Mara, Gray, and Charlie as my pool. But I'm only going to pick 2 of them. Okay? So in a permutation, I would say 3 factorial divided by 3 minus 2 factorial, if it were a permutation. And in a permutation, order matters. So that would mean Mara comes in first place, Gray comes in second place. And that's different from Gray comes in first place, Mara comes in second place. Okay, but in a combination, order doesn't matter. So if I say Mara and Gray, that's the same thing as Gray and Mara. So if I just looked at the permutation, I would be considering the fact that the order matters, and I'd be double counting Mara and Gray as one option, and Gray and Mara as another option. Whereas in a combination, I want to consider those being the same thing. I want to consider those being distinct. And that's why I need to divide by this 2 factorial as well. 2 factorial will really compute how many ways. We'll compute how many ways, I'm getting ahead of myself, can you arrange the 2 you pick? So how many ways can I arrange Mara and Gray? And the reason we have to divide by how many ways you can arrange the 2 you pick is because we're double counting that as 2 different separate scenarios when I'm just computing this. And if I divide by how many ways you can arrange them, I'm no longer considering Mara and Gray the same as Gray and Mara. So I'm dividing out some options, which will give me less options. Combination, you'll have a smaller number because you're not counting those as distinct. And this really, really connects to the conversation we had about, how many different permutations are there of the word Illinois. Same kind of idea here. If you have questions about that, please ask in class. Before we move on to some examples, I just want to show you some alternate notation for combinations. This one should look familiar because we talked about this in permutations, but this is another context you might see a combination in. So if I said our 3 choose 2, you might see it written like this, and you should understand that this means find the combination or calculate the combination. Okay, so how many ways can you pick a team of 3 people from a group of 10? So 10 is like the pool you're choosing from, and you're choosing a team of 3. So how many you want, which is kind of like what I was just talking about. Order doesn't matter because you're choosing a team of 3, and a team of, let's say, Trevor, Sophie, and Max is the same as a team of Max, Sophie, and Trevor, which is why this is a combination, not a permutation. So you can set this up in different ways. You can say I'm 10 choose 3. You can say it's 10 choose 3. You can write out the formula would be 10 factorial over 10 minus 3 factorial divided by the repetitions of arranging those 3 people. And you could go ahead and compute that out, and this would be 7 factorial. You can cancel things out, yada, yada, yada. I wanted to show you how you can do this in your calculator to be a little bit more time efficient. So first of all, I should turn my calculator on. And if you hit the math button, there's all that square root stuff you've been using, fractions, whatever it is. If you go to PRB, that stands for probability. Anything you need for probability is here. So like number 4 is factorial. But if I want a combination, that's NCR, like you see it here. Now, if you have an old calculator like this one, you have to hit the pool first, so it'll look like this. So I have a pool of 10, then I go over to probability, go to NCR, hit enter. So this is saying 10, my combination, and then you're choosing 3. So it kind of looks like how it looks over here, the 10 first, then the 3, and you hit enter. It'll compute it for you. So there are 120 ways to pick a team of 3 people from a group of 10. I'll leave this one for you to try alone. And I will also leave this algebra application for you to try alone, but I'll help you set it up a little bit. So remember, this is the pool, and this is what you want. So you're just using variables to kind of compute, not necessarily number of options, but you're going to compute a combination. So you have your n factorial, which are n in this case. I guess I should say this is n and this is r or k in this case. So our n is n plus 1. So you have n plus 1 factorial over, you're going to subtract these two, n plus 1 minus n minus 1 factorial times k factorial, which is n minus 1 factorial. Okay, I'm going to give you some advice, but I want you to work on the solving. This is an algebra class. I think it's a good idea to simplify this first, and then I think it's a good idea to think about how does n minus 1 or n plus 1 or n minus 1 expand. And you may be thinking about recursive formulas for sequences. Right? We talked a lot about what does it look like if you have n minus 1 and then the next term or the previous term. Think about how you would expand these factorials out and then see what cancels. So I want to leave that for you to think about because that's a good challenge problem. So basically that's how you compute combinations. We try to make sense of the formula, but we didn't necessarily derive it. So if you have any other questions, please come to class and ask them. Have a good night.